Hello and welcome to week 1 of the Cross Society Python course. I'm Keegan and I'll be giving you a brief overview before moving on to the content of week 1. So, what is XSOC? XSOC just means Cross Society, and the reason for that is that we have 3 societies here: the Computing Society, Warwick AI, and Warwick Coding Society, and we've all come together to make a joint Python course. This Python course is for complete beginners, so we assume no knowledge of programming before this. There are 6 of us in total, 2 from each society, and you can see our faces here, and we try to split up the work fairly equally. A brief overview of the course. In week 1, which is this week, we'll cover variables, data types, and debugging. In week 2, coding will cover flow control and functions. In week 3, we'll listen loops. In week 4, AI will cover file handling and the command line. In week 5, they'll cover exception handling and classes. And finally, in week 6, we'll be covering efficiency, compactness, and readability. There's also a project that we're working on, starting from week 2, and that's called Wahoot, which is definitely legally distinct, very legally distinct, from Kahoot, and has nothing to do with that in any way whatsoever. It's a totally original idea, and it is developed jointly by AI and computing, and hopefully we'll see you start to work on that next week. Also, a brief word of warning. You probably heard someone say something to you at some point like this: everyone can code. So, like I said, someone you know, probably. But that doesn't mean that it's going to be easy, right? We've obviously put a lot of effort into making this course, so as long as you're happy to engage with that, then that's great. You'll hopefully have lots of fun, but just don't expect to learn everything within 12 hours. This is not a comprehensive guide to Python, to programming, to computer science as a whole. This is just a small subsection of that, which covers the broad concepts. After all, if I could snap my fingers and suddenly understand everything there is to know about programming, I wouldn't need to bother doing my degree. Now, let's begin the content. By the end of today, you should know all of these things, but the important part is that you know how to make basic Python scripts. Let's talk about what a program does, right? So a program does things to data, but that's not really that specific, is it, right? So what things can we actually do? In what order do these things happen? And what can a program ultimately produce? And also, when I say data, that's also kind of ambiguous, right? So what types of data? How do we represent this data in Python? And also, how can we reference this data? How do we do things with it? I think we should start off by discussing variables. So you've probably seen variables in the context of maths before, something like this. And in this case, x has a name, x, and x has a value. So in this case, I believe that x is 69. And in programming, it's kind of similar, right? So hello has a name, hello. And hello has a value, and in this case it's being assigned 38. Now, you'll probably notice it says equals, but what that actually means is assigned. So in programming, we write equals to mean is assigned, not actually, is equal to. And also, you should be aware that we have to represent things by data types. This is not really 38 in the computer, it is a bunch of ones and zeros. But because we wrote 38, here we're telling Python that this is the integer, the whole number, so positive or negative, 38. I mentioned that variables have a name. There are many different ways to write these names, but there are rules. Firstly, the name cannot contain any spaces. So if you put a space in the middle of a name, then it will not know what you are talking about. Also, a name cannot start with any digits. And finally, you should represent spaces with underscores. This is mainly what we call a style convention, so you don't technically have to do this, it's just preferred. Now, we can assign to some variables, that's great, but our program doesn't actually do anything, or rather it doesn't output anything. This is because we haven't told Python to actually output that. So, let's fix this. We're going to introduce the print function, and no prizes for guessing what it does. When you put in print 7, it goes, and it gives you an output, 7. If we assign to a variable, so here we have the name 7 is assigned the value 6, and then we print out the name 7, which is 6. Every function has to be referred to by name, in this case print, and we call the value between the brackets an argument. So that's the data that the function uses. For now, think of functions as magical black boxes, so you put something in, and you might get something out, you might get something else happening. So they either do something, or they evaluate to something. Another thing worth mentioning at this point is about going from top to bottom. So you can almost think of programming as kind of like a cookbook, right? And the reason for that is that when we have any statements like this, we always execute them each line by line in Python from top to bottom. We have mynum is equal to 4, we print 7, and then we print mynum. So this script would output 7 and then 4. Hopefully that's fairly intuitive. A brief aside, you can also have multiple arguments for functions. So print function actually has a 2-argument version, like this, and here we will be able to print both out in the same line. So here we have 13 and -9. And here we're separating out multiple arguments with a comma. It's also worth noting that you can rewrite variables. So what I mean by that is that if we have cool number equal to 8, epic number equal to -16, and we print them out, well, you get what we expect, right? We'll get 8 and -16. But then, because we're going from top to bottom, we can reassign these numbers later down the line. So now epic number is -512, and cool number is 1024. So when we print out again, we get the new values, so it's updated as we go down. Hopefully that's fairly okay so far, so we're going to move on to operations. Now, there are quite a few operations, and you've probably seen a lot of them before, but in different contexts. You can see that the top 3 are fairly obvious, right? So we can add 2 numbers, subtract 2 numbers, multiply 2 numbers, but the bottom 3 are more interesting. There are actually 3 ways to divide something, and they all have different outputs. With the first one, when we divide 2 numbers, we always return a float, which is actually a new data type, which I will talk about in a second. Whereas the bottom 2 operations are associated with integer division. So we have the quotient that you'll get returned, and the remainder that you'll get returned. So it will always return a whole number for both cases. As I'm sure you're aware, not all numbers are created whole. So we have this script here that will do float division and also quotient division, and we can compare the two. So if I did print 7 divided by 3 with the normal division, I would get something like this. If I was then to do print 4 divided by 4 with the normal division, I would then get something like this. Now you may be thinking, why is that 1.0 and not 1? And the reason is that it always returns a float. So a floating point number will always have the decimal point on the end. It is a different data type. Whereas when we do the integer division, we get the following. We get 2, so it chops off the end. We round down to the integer below. And for integer division, so 4//4, we get 1 as expected. Also, these are comments. So if you put a hash on any line, then everything after that hash will not be counted as code, including the hash itself. You may also be wondering, why is this not 4? And the reason for that is a little tricky. It's to do with the way, again, that computers store numbers, but they can only store them to a certain precision. And because of that, there's occasional rounding errors, or occasional floating point errors, as we call them. In this course, we won't need to worry about that. And of course, you can declare floats directly. So if I go x is equal to 2.6, and then I print 5.4 plus x, then it prints out 8.0, not 8. Again, this is because it's a float and not an integer. It's also worth noting that operator precedence applies. So, for example, if there are no brackets here, then the division would happen first. The rules follow binmass, your favourite thing. If the operations have the same precedence, so binmass we can't quite figure out, then we go from left to right. Running along the script, we have foo equal to 5, bar equal to 2, and then baz is equal to foo plus 3 times bar. So we work out 3 times bar first, that's 3 times 2, so that's 6. Then we add it to foo, which is 5, so 6 plus 5 is 11. And that's the new value of baz. Now, we do 50 into division with 4 plus baz, so 4 plus 11, that's 15. How many times does 15 fit into 50? And the answer is 15, 30, 45. We can't go any higher, so it's 3. So biz is 3. And then finally, we print out biz minus 1, which is 2. I'd also like to discuss this example. So here we have a equal to 3, b equal to 2, and here we're using a twice. Now, we can do this because we care about the right-hand side of the equation first. We take a plus b, so that's 3 plus 2, and that's now 5. And now this is assigned, so here we consider the right side of the equation first, and then we assign it to the left-hand side. and now we can reuse a as 5 on the next line. A equal to a times b, that's equal to 5 times 2, which is 10. So now a is 10. And when we print out a, we get 10. So the shorthand for doing this variable is equal to variable plus something, or variable times something. And that's like this. So these two code snippets are equivalent. And tasks 1 to 4 in the notebook, link in the description, cover these concepts. Let's talk about exceptions. You've probably already encountered them, maybe multiple times before. Here's an example. So the blue screen of death, as some like to call it. Exceptions will pop up whenever something goes wrong with your program. And stop the rest of it from executing. It won't cause your entire PC to crash though, don't worry. It's normal to run into problems with your code. Everyone makes mistakes when programming, even professionals. So we can generally put these problems into 3 categories: syntax, runtime, and logic. Syntax is where your script doesn't actually follow the structural rules of the language. So for example, putting the space in that variable name, like I mentioned earlier. Runtime is if the structure's fine, but you actually try to do something that's prohibited by the language. So for example, dividing by 0. And logic is where the script runs perfectly fine, there are no errors, it just doesn't do what you wanted it to do, which unfortunately Python does not pick up. So Python exceptions are only going to catch the first 2, whereas the last one is on you. And here's what happens with an exception. You can see that I'm using the variable z, but I haven't actually defined what the variable z is. And in this case, it's quite a helpful error, right? It said that it's called a name error, and you can see that it's even pointing to the line number that it happened on, line 3. And name error name z is not defined. This is a helpful error. There are also other, more unhelpful errors that you will encounter. Not all exceptions are as nice as this to understand, but this is an example. And again, link in the description, tasks 5 and 6 in the notebook cover these concepts. Let's talk about strings. But first, I want to have a little note on spacing. Normally, Python ignores any spacing after the start of a line of code. Each of the 3 lines at the top here are all equivalent. They do exactly the same thing, even if they may not look as nice as one another. Personally, I would prefer to use the second one. However, note that you can't have any spacing before the first character. This type of spacing is called indentation, and it's important for the concepts we'll be covering from week 2 and beyond. For now, try to avoid putting any spaces at the start of a line. Well, what are strings? Well, Python uses them to represent text by stringing together a collection of letters in some order. We'll revisit them in more detail when we discuss arrays, but for now, just think of them as a big chunk of text. So here, because we've got some text, the spaces count as literal space characters, and it prints out like this. Because we're treating spacing differently, we have to know where a string starts and where a string ends. So we do that by using the single quotes or double quotes, and we can surround the string in either. Generally, we prefer to use double quotes where we can. You can also perform operations on strings. So for example, if I add 2 strings together, it combines them into one. The more common term is called concatenation, so like so. You can see that because we don't have any spaces inside the strings themselves, first half and second half kind of mush together, and there's no space between the 2 words here. However, if we try to add a string with an integer, we get a type error saying that they don't match. So we can only concatenate string, not another integer, to another string. Tasks 7 to 10 will generally cover the concepts of strings. It might seem a little strange at first that we can't somehow combine this string and this integer. But it is possible to convert between data types to allow us to do this in the way we'd like to. Here are the casts for the data types we discussed today. There's an int cast, a string cast, and a float cast. And whatever we put in between these brackets, Python will try and do its best to convert that variable into the new type. For example, if I have a string variable that says -3, and I convert that to an integer, which works, and they add 4, I get 1 as an integer. Then I can convert it to a float, so that would be 1.0 minus 0.5, which will give me 0.5, and finally back to a string, so that would print out 50p. However, you have to be careful. I specifically chose these examples because they work quite nicely, but that isn't always the case. So there are what we call conversion subtleties. When converting to a string, that generally always works, right? There's always a way to convert a number to a string. However, the same cannot be said in reverse. Let's look at some examples. In the first example in the top left here, int of the string 42 does work because we can see a way to clearly convert it. And again, if I assign to a variable and I convert that, that's absolutely fine. If I try and convert the word 6, then it doesn't convert because it doesn't recognize it as being a number. It's similar with float. If I have float of 4.2, it can see that it can convert that into a float type. If I set y to be equal to the word 9 and try and do float of y, it unfortunately fails because there is no way that it can see to convert that. And finally, if I try to take the int of 4.2 as a string, it also fails, and that's because of the way that the integer conversion algorithm works. It does not see this as an integer because it found a foreign character, in this case a dot, where it didn't expect to see one, so the conversion fails. So that covers two sides of the triangle, but there's a third. What happens when we convert an integer to a float? And this can do something called widening. And what I mean by that is, if I combine a whole number and a floating point number, then Python automatically converts the integer to a float where necessary in order to perform operations, and it prints out 11.2. What's also helpful is that the conversion is only temporary, it only happens for that specific operation, which means that our number is left intact. This is called an implicit cast. You can cast more explicitly, but you don't have to. And finally, what about from a float to an integer? Now, this can actually lose information. So, if I were to have e equal to 2.7182818, and I was to cast that to an int, then we would lose everything after the decimal point. So it would all get chopped off, and we were left with the engineer's preferred version of e. This is called type narrowing, because we're losing information from the cast. And that's it. Those are the subtleties that you should be aware of when you're converting between data types. Tasks 11 to 13 will cover these concepts. One more thing. This is on input. So previously we've been sort of setting variables and then doing things with those variables that we've set. But we don't have to do it like that. We can accept user input. When we run the program, it will stop execution at the line where the input is, and it will prompt the user to input something. The function always returns a string value. So whatever you put in, it will return a string of what you entered. So if I ran this, I will be prompted to enter something. So in this case, I'm going to enter Bob. And then the script will execute like normal, and it will print out, "Hi Bob, I'm Dad." So how do we input integers? Well, it's pretty similar. So again, remember, it always returns a string value. When we get the variable, we can then convert it into an integer and do something with it. So in this case, it asks us to input our age, and so if we're 18, it will then say, "Wow, you'll be 19 next year?" So that's all fine. Our final task, task 14, covers this concept. There's also a bonus task at the end if you get time to do those. Here's what we've covered today. Firstly, programs do things to data, right? But now we know what things we can do, some of them. We know in what order these things happen, and we know what our program can ultimately produce from that. We also know some of the types of data, and how we represent that in Python, and how we reference that data. And so you can see that what I mentioned before, operations, variables, data types, exceptions and basic debugging, typecasting, and use it basic functions. We've covered that all now. But there's one thing left, and that's that you should be able to make basic Python scripts. So, we've got a workshop for you. It's a Jupyter notebook, which is basically Python with text box throughout. It's quite nice to use, and you can run all the Python code within that. It's all self-contained. You'll open it with Visual Studio Code. Not Visual Studio, preferably. That's a much bigger install. And it's a very good programming tool, Visual Studio Code. And there are 15 tasks. There are 5 more bonus tasks, if you would like to try them. It's quite simple to install. So firstly, you need to have Python to run Python. So go to python.org/downloads, install the latest version, which at the time of recording is 3.10.7, and make sure to tick the Add Python to Path box. That you don't necessarily need to do that, but it will save you a lot of pain down the line. Step 2 is to install Visual Studio Code. Again, there's a link. And please get the Python extension pack. So this also gets recommended when you open the notebook. And finally, step 3 is to open the notebook. So if you head to go.uwcs.uk/Python, then you'll get a Google Drive with all the materials for this week. And that's everything. Thanks for watching, and I hope that you find both this talk and the notebook useful.